Hi everyone, I wanted to go through some Lewis structures that represent exceptions to the octet rule and or if you are dealing with a structure of a polyatomic ion. So on a handout that you should have, or you can look at the image here on the screen, the guide that I created for drawing Lewis structures lists some very common exceptions that you will have to the octet rule, okay? In particular, this third period elements and below can have what's called an expanded octet. They can have more than 8 electrons when they are the center atom in your drawing. This usually does not happen when they are the terminal atom. If they are in the center, a third period element and below can have an expanded octet. The other thing that we want to focus on this example video is if you are dealing with a polyatomic ion, you have to add or subtract, as maybe, electrons based on the charge of the ion when you do your total valence electron count. So let's look at some examples. SF6, sulfur hexafluoride. Again, place the least electronegative element in the center of your drawing. That is often the first element written, not always. In this case, sulfur is much less electronegative than fluorine, which is the most electronegative element. So I've got 6 fluorines that I'm going to draw around this. Sulfur, and then I'm going to do my count. Sulfur has 6 valence electrons. Each fluorine has 7 valence electrons. So a total of 48. Start by connecting each terminal to the center by a single covalent bond, 2, 4, 6, 8, 10, 12. And then however many you have left over is what you fill in as lone pairs, starting on the terminal atoms. And the goal would be to at least start by giving everything an octet, adding your lone pairs. So fluorine, which has to follow the octet rule, it always has 8. I'm going to start with this one. It doesn't matter which one you start with. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36. Okay. All right, I'm out of electrons. So now it's time to check the octet rule. Each fluorine does indeed follow the octet rule. 1, 2, 3, 4, 2, 4, 6, 8. Sulfur in the middle here has 2, 4, 6, 8, 10, 12 electrons around it. 12 electrons. It's an expanded octet. Is that allowed? Is that okay for sulfur? Yes. Sulfur is a third period element, period 3. Third period and lower can have expanded octets if it's needed in that compound. So this is indeed the Lewis structure for SF6. Xenon tetrafluoride. This is one of the first discovered noble gas compounds, because prior to this we didn't think noble gases could actually form compounds, but this is one, xenon tetrafluoride. So I've got xenon in the middle and 4 fluorines. So add up my valence electrons. Xenon has 8. Each fluorine has 7. I got 36 electrons, similar to what I had over there. Start off with a single bond between the center and each one. So now I have 28 electrons to fill in as lone pairs, starting with these terminal atoms on the outside. Now, a trick that sometimes we use in chemistry when we get tired of doing dot, 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 is for a lone pair, you can just draw a line. And you know that that represents two dots. You can do that, but I'm not going to in this demonstration. 1, 2, 3, 4, 5, 6. And I'm giving all my fluorines an octet to begin with adding lone pairs because I know they need it. So how many did I just use? I used 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. I still have 4 more electrons. I have to place these other 4 electrons as lone pairs on the center atom. And then that used all of them. Check the octet rule. All of my fluorines have an octet. My xenon has 2, 4, 6, 8, 10, 12. It's expanded. It's okay for it to be expanded because it is third period or lower. And lastly, a polyatomic ion. Remember, for polyatomic ions, you have to add or subtract a charge. This charge, negative, means when we add up our total, we're going to add one extra electron to account for that negative charge. So in my drawing, I'm going to put boron in the center and the 4 fluorines around it. Add up boron, 3 valence electrons, 4 times 7 for my fluorine, and then plus 1 more electron for the charge. Okay. I believe that gives us 32 total. So 2, 4, 6, 8. I just use 8, creating bonding pairs. Okay. 24 electrons, 4 fluorines. Each one is going to take 6 lone pair electrons total, right? 3 sets. That is going to use up all of my electrons. And now for a Lewis structure, for an ion, what we do is after we draw the sketch, we enclose the entire sketch in brackets and put the charge outside the brackets. This is the correct format for an ion as a Lewis structure. Okay.